Hi everyone, in this video, we're going to dive deep into one of the most fundamental data types you'll encounter in any programming language, Booleans. Understanding Booleans is crucial because they are the cornerstone of all conditional logic in your programs. Let's begin by exploring what Booleans are and how they work in Kotlin. At its core, a Boolean represents a truth value, which can only be one of two states, true or false. Think of it like a light switch that is either on or off. This simple concept is incredibly powerful, as it allows your programs to make decisions, control flow, and respond to various conditions. In Kotlin, you declare variables using either the val or var keyword. The val keyword is used for read-only references, meaning the variable can be assigned only once after it's initialized and cannot be reassigned a different value later. The var keyword declares a reassignable reference, allowing you to change its value multiple times after its initial assignment. Kotlin is a statically typed language, meaning the type of every expression in your program is known at compile time. However, Kotlin also features powerful type inference, which means the compiler can often automatically determine the type of a variable from its context, saving you from explicitly declaring it. Let's look at some examples. Example 1. Declaring a read-only Boolean using val with type inference. The compiler infers is Kotlin fun is of type Boolean. Example 2. Declaring a mutable Boolean using var with explicit type. Explicitly declaring is logged in as Boolean. Example 3. Reassigning a var Boolean. This is allowed because is logged in is a var. Example 4. Trying to reassign a val Boolean. This would cause a compilation error. Error. Val cannot be reassigned. As you can see, the compiler quickly identifies is Kotlin fun as a Boolean because its initial value is true. The Boolean type in Kotlin has only two possible values, true and false. These values are essential for building conditions and expressions that drive your program's logic. Kotlin provides standard built-in logical operations for Booleans, which are widely used in modern programming languages. A logical OR, this operator returns true if at least one of its operands is true. If both are false, it returns false. A logical AND this operator returns true if both of its operands are true. If even one is false, it returns false. Negation operator. This is a unary operator that reverses the truth value of its operand. If the operand is true, it returns false and vice versa. An important characteristic of the logical OR and logical AND operators in Kotlin is lazy evaluation, also known as short-circuiting. This means that the right-hand side of the expression is only evaluated if it's necessary to determine the final result. A for, if the left-hand side is true, the entire expression will be true, so the right-hand side is not evaluated. A for and, if the left-hand side is false, the entire expression will be false, so the right-hand side is not evaluated. Let's illustrate this with an example. This lazy evaluation can be used to your advantage, especially when the right-hand side involves a more complex or resource-intensive operation, or when it depends on the left-hand side not being null to prevent null pointer exceptions. Kotlin's type system is designed with strict null safety to help developers avoid the dreaded null pointer exception, NP, often referred to as the billion-dollar mistake. This means Kotlin distinguishes between nullable references, which can hold null, and non-nullable references, which cannot. By default, Boolean variables are non-nullable. If you want a Boolean variable to potentially hold a null value, you must explicitly declare it as Boolean with a question mark. Is available is non-nullable Boolean. Error. Null cannot be a value of a non-nullable type Boolean. User-accepted terms is nullable Boolean. Is logged in nullable is also a nullable Boolean. An important rule in Kotlin is that you can only use a non-null Boolean for any type of condition. This prevents runtime errors that might occur if a null value were used where a true or false was expected. If you have a nullable Boolean and need to use it in a condition, you'll need to handle the null case explicitly, perhaps by providing a default value using the Elvis operator, or by performing a null check, using the Elvis operator to provide a default value. If user consent is null, consent status will be false. Explicit null check. This condition is only true if user consent is not null and true. One of the significant differences Kotlin brings compared to Java is that in Kotlin, everything is an object. Unlike Java, which distinguishes between primitive types like Boolean, int, and their wrapper objects like Boolean integer, Kotlin removes this distinction entirely from a developer's perspective. This means that even Boolean values in Kotlin are treated as objects. You can theoretically call methods or access properties on them, just like any other object. However, this doesn't mean Kotlin is less efficient. The Kotlin compiler is very smart. At runtime, for efficiency reasons, the compiler optimizes these object types. For example, a Boolean in Kotlin is typically compiled down to Java's primitive Boolean type in the resulting bytecode whenever possible. This optimization ensures that your Kotlin code runs just as fast and memory efficiently as equivalent Java code, while still providing the convenience and type safety of an object-oriented language. Okay, all right, guys. We've explored the Boolean data type in Kotlin, covering its declaration, fundamental true, false values, and standard logical operations like and. We delved into the efficiency of lazy evaluation and understood the critical role of null safety with nullable Boolean types. Finally, we learned that in Kotlin, Booleans are objects, a design choice that simplifies the language while retaining performance through compiler optimizations. In our next video, we'll dive into Kotlin's next component. So, see you guys in the next lecture.